Although we're still technically on Unit 1, we are starting Unit or Chapter 2 as of today, which is on our forces and free body diagrams. And recall from grade 11, if you've taken grade 11 physics or currently taking it at the same time as this course, that a force is merely a push or a pull. That is our best definition at its easiest terms, and that might mean something like compressing, stretching, or twisting objects. And let us recall a few basic types of forces that we have. The first type of force that we could have is the force of gravity. And remember that the force of gravity is an attraction force. And that we can calculate the force of gravity fairly simply. If we have a 5 kilogram soccer ball in reference to the Earth, we can calculate the force of gravity by m, the mass, multiplied by the acceleration due to gravity. So that will be 5 multiplied by 9.81, or 49.05, and that, if we go to significant digits, is 50 newtons. And a little bit of a sidebar here, just remember that 1 newton, which is the SI unit for force, is equal to 1 kilogram meter per second squared. We also have our normal force, Fn, and that opposes the force of gravity. I should remind ourselves up here when I'm talking about a push or a pull, that is usually our applied force Fa. We have our force of friction, which opposes the applied force. And when we talk about the force of friction, there are really 3 main types of friction that we'll see. First one being static friction, Fs, and that prevents stationary objects from moving. That's one type that we have. We have our kinetic friction. Fk, and that is a force that acts against moving objects, trying to cause that moving object to slow down. And another type of force of friction that we also see, but we don't really cover it much in this course, is our air resistance. And that is a force that's acting against objects which are falling through the air. And last but not least, we should remember our tensional force. Ft, and we see the tensional force in objects by objects that are being pushed or pulled. This is a scribble there. By a rope or string. Looking for my paper. Here we go. And let's continue on here. Recall, again, we can use free body diagrams. In free body diagrams, FBD show the forces acting on an object. So for example, if I was to push an object to the right, if I drew a systematic drawing, we would see that we have a box on the ground, and there would be some person, let me make sure that they have hand, that's actually pushing that object to the right. If I think about the forces that are actually acting on this object, that's FBD, my apologies there, free body diagram. We have my box, which still has the force of gravity acting on it. Equal but opposite is my normal force that's acting on the object. And because this object is moving, my force applied is much greater than the force of kinetic friction that is acting on it in the opposite direction. So those are the objects that are acting on boxes, and free body diagrams allow us to show these objects or these forces that are acting on the object that we're analyzing. And we are able to calculate the net force. And the net force is the sum of all forces acting on an object. So example that I have for you today. We have a soccer ball. And it is kicked with a force of 32 newtons east 40 degrees north. And has a force of gravity of 15 newtons down acting on it. So let us calculate the net force acting on the soccer ball. We start this question with a free body diagram. A soccer ball kicked with a force of 32 newtons and a force of gravity downwards of 15 newtons. And this angle here is 40 degrees. And we see here that our force, let's call it F1, of 32 newtons can be broken into its x component and to a y component. So to determine the net force acting on the object, we'll break this question down into its x and y components. We assume that that is a 90-degree angle, and I see that Fx in relation to 40 degrees is on the adjacent. So F1 of x will be 32 cosine 40 degrees, and calculating that is 24.5 newtons. And you will see, my apologies, I forgot, always I have to do this, north and east are positive. In my y direction, F1 of y would be 32 sine 40 degrees, and that is 20.6 newtons. Along in my y direction as well, I also have that force of gravity. Let's just call that F2. That will be 15 newtons. And seeing that it's only going downwards, it's only in the y direction. So therefore, in the x direction, my total force is 24.5 newtons east. In my y direction, 20.6 minus 15 tells me that my total force in the y direction is 5.6 newtons north, which is quite handy for us in this case because I can break these components into x and y, and I now see f at x, tail to tip for my vectors, 24.5 newtons. Fy is 5.6 newtons, and this makes a right-angled triangle. So to determine my overall force, I can use the Pythagorean theorem. By taking 24.5 squared, adding 5.6 squared, and taking the square root of that. And that is 25 newtons. And I now must calculate theta. And same as before, opposite and adjacent tells me in trig that would be tan theta as 5.6 over 24.5. So theta is tan inverse of these two divided by each other. And calculating that, theta is 13 degrees. So here are my two pieces of information. So therefore, the force acting on the soccer ball is 25 newtons east, 13 degrees north. A lot of people have been doing very well emailing me questions. Please, anytime you have any troubles, continue to do so.